Hello, and welcome to AWS Review, a weekly look at what's happening at AWS and how it may change how you do business. I am your host, Michael Krause. I am the Chief Technology Officer at Charter Solutions, where we help organizations change and innovate quickly by accelerating their acquisition and use of data.
And I'm your co host, John Affolter. I'm a lead technical architect on the AWS specialist team at Salesforce, where I work with potential customers, helping them envision the possibilities that AWS and Salesforce enable.
Excellent, thank you. So today we're continuing our kind of theme of AI ML, and today we're going to be taking a look at machine learning automation on AWS. So, John, machine learning automation or ML ops, how do you kind of define that? What do you think of when you think of ML ops?
Well, I think it's obviously a really broad topic, but ML ops is an automation or a operationalizing the processes that need to happen to be able to have a machine learning product or suite of products or platform be able to work seamlessly and without any issues, and everything from the development of the models all the way through the deployment, and then also the tracking and the observability on those models as well. And on top of that, being able to automate and change different aspects within any part of that pipeline, whether that be, from the beginning stages on the ingest, whether that be, changing different elements of what needs to be done as far as pre-processing or data engineering on the front end, how things need to be formulated within to different formats so a model is able to process it, and then also deploying it onto an application. And it's one thing to have an insight come from a machine learning model. It's another thing to be able to deploy an endpoint, and it's another one to be able to have an application that can process and run the inference on that model. And then it's again another one to be able to have the results of that be fed back into a feedback loop and observe to make sure that you're always having the optimal model. So
I'm
it's a
glad
lot
you
there.
mentioned. I'm glad you mentioned the feedback loop because I was going to ask about that. One of the things that historically I've seen is that the refresh and retraining process oftentimes falls back onto the development side of it. So with ML ops, is there more automation, at least for some models, to freshen those models up based on new information?
Yeah, I mean, there's a lot of things within AWS. This is almost a good one for you too, because you're the master of architecture, but of just especially choices of where to run the compute. But within SageMaker specifically, there's a lot of really cool features that allow you to be able to, for example, the feature store, where you can store different features that you've engineered to be able to be utilized in models later. And then you also have the model registry, to where you can register a model that you've already processed, or you can be able to track the actual progress over time. So like when you said to go retrain it, you can figure out where the model is improving and where it's falling short. And having that within a SageMaker pipeline, then all of a sudden you've linked together all of these different pieces. And not only have you linked together the pieces for an end-to-end machine learning application, but you've also stored it at different places to where you can go access that later. And if you need to retrain, you can follow the lineage of how you got to that point. So you're always being able to run another SageMaker tool, SageMaker, the experiments. So you can run experiments and test different models, test it out against different chunks of data, and just also be able to track that over time as well. So
Excellent. So you've mentioned SageMaker, and people who may be following our show here have heard it recently in other shows. Tell me a little more about what AWS has and what's available in SageMaker around MLOps. Are any specific capabilities or features or tooling that you think is interesting to discuss?
Yeah, so you have to think of it too in different stages of when you're developing the model as well. And each stage has its own operational pieces to it. But let's talk about when you actually want to deploy the models as well. You can save things in SageMaker projects, which is going to save a specific type of project. You can build the specific pipelines, which will handle pre-processing. It will also register it in, like I said, in that model registry. That'll get registered in there. You can also kick off and run through different hyperparameters and test those out, and you
Hmm.
can do that manually, or you could leverage things like SageMaker Autopilot or Canvas, which are going to run through all of these different choices within hyperparameters, which are basically the different levers that you pull on to manipulate how the model is getting influenced, whether that's from loss functions or other things dependent. It could be model dependent, but
Hmm.
it basically allows you to manipulate and really optimize that model for your specific data. And each one of these steps has to, you want a starting point and an ending point, so you're making sure that you're always picking the optimal model. And the
Right.
thing that AWS and SageMaker does is it brings it all together, where you might be doing a lot of this in a lot of different technologies, but you never had that single pane of glass where you could connect data sets, you could run your model, and then you could go to deploy that. So SageMaker gives a lot of different options to be able to deploy models, whether you want to do batch transformations and put an endpoint out that way. You can have serverless endpoint inference. You can deploy just an endpoint that's always running that you can go and run real time on there as well. So there's a lot of different options that get kicked off in other resources as well, but it's all kicked off from SageMaker, which is a
Excellent.
really great experience.
So let's kind of maybe walk through the process of, from idea and experimentation through production, and take a look at what capabilities are available to support this, and to maybe understand how companies could leverage that. So let's start kind of on the development side. So one of the things that I've read, and I haven't really dug into deeply, is that the SageMaker MLOps tooling provides some uplift for the data scientists with regard to taking away some of the heavy lifting around environment or around collaboration. Um, can you tell me a little bit more about that?
Yeah, so that's similar to the projects and then also the experiments that I was talking about
Yep.
earlier. SageMaker, I just think about when I was in college and doing my machine learning projects. It would take me probably about an hour and a half to 2 hours just to set up my virtual machine, make sure
Yep.
that the image is set up the right way. And then I had to make sure my notebook was configured the correct way. Obviously all the packages and everything that I needed to utilize. All of that I had to worry about. And, well, let's say I built it in a certain framework or a certain, I built it on a certain type of image. And then I wanted to do inference somewhere else.
Right.
I might have to worry about, changing a bunch of things over around or creating a wrapper or whatever that may be. But just that process would take me a few hours.
Right.
With SageMaker, I can sign in uh, and come right to a home screen to where it gives me options where I can do a jump start, which is basically, a a guided or a guide based on certain use cases where it helps get you set up. It helps you jumpstart and get your environment set up, all of your, all of the VM, the image, everything that you want to do, and also connected to the notebook. That's done for you, and it's also
Right.
tracked. And you can see all of that action over there, and then you could save it in a project, or you could run different experiments, and then those experiments can be shared, and you can come in and the other data scientists can come in and collaborate with you in real time, and you can have uh, a place to where all these little random changes that you make, and if you have ever done a data science project, obviously you try out a bunch of different things, and sometimes you can catch lightning in a bottle,
Yep.
and then all of a sudden for some reason something crashes, and then you've lost everything that you've done from start to finish. There could have been one little thing that you did differently in setting up your image that could totally change the way that your model was going to be run, or if it did run at all.
Right.
So all of that's done for you, and it's right there in collaboration, and you can track it. So you can track it all the way from the data source all the way to deploying it, and all of that's getting observed along the whole way. And Michael, with working in distributed applications, observability is a nightmare. And
Yes, observability can be a very big nightmare. You
so
know,
I think that SageMaker really gives it allows a lot of the optimization that you might have had to do within building the actual application. It can be done on the back end, with the best, I guess, one of the word I'm looking for, the best, the optimization that is found to be, the most accurate, save you the most amount of money, exactly form fit to your model.
right.
SageMaker is going to figure out what CPUs or GPUs are going to do that for you, which that's a whole job in itself. So
So, in addition to the observability and like you said, quick setup, quick getting to a point where you can actually do stuff, and not wasting a whole lot of time configuring environments, right? Automation is another topic. So I know that you can build pipelines, to deploy these things. Um, how do these pipelines apply on the development side and the training side, and then eventually to deployment in towards a production environment? What tooling works there?
so as far as just deploying it out within the production environment.
Or no, I'm thinking even in the development environment to start, right? What opportunities are there for automation, via pipelining or things like that, even in the development environment? Then we'll talk about deployment to production afterwards.
Yeah, I mean, there's, it really, even in just building everything out, you can connect all of this into your CI/CD pipeline as well. So all of the different tools that come with AWS, code build, deploy, you can connect to GitHub, and you can also register certain GitHubs. You can create different repositories right there within the actual console as well, and then you can access a lot of these different frameworks that are already built out, and then all of the dependencies and libraries you can access to be able to develop really quickly as well, which that's going to allow you to be able to deploy it in an application a lot easier, because all of those things that are going to cause a lot of issues, it's all handled already. So when you're actually developing now, there's two different realms of the development, right? There's the
Right.
developing of the machine learning algorithm, and then there's also the training aspect of it,
Yes.
but there's
Yep.
also the application that is run within there. So maybe this is a good kickback to you. How much of the application, the code in the actual application, has to be figured out as far as optimizing it to be able to actually handle these machine learning workloads?
It'll depend on how the machine learning workloads themselves are deployed. So from a uh, application side of things, I look at the model as a black box, right? It's an interface with a contract that says you feed this data in, I will give you this data structure out,
Mm-hmm.
right? And what's inside the box, I don't care if it's Java code, I don't care if it's a statistical model, I don't care if it's a machine learning model. I give you data, you give me something back, right? I tell you what my face looks like, and then you tell me whether or not I'm, you know, you know, susceptible to certain diseases, right? So from that perspective, having a clear contract is important, but the other side of it is balancing scaling between the two, right? So if I'm deploying my model independent of my app and I'm doing a call between them, right? So if my model is fronted by a REST API and it's all managed by, a SageMaker APIs, and I've building up a model and I'm scaling to, hundreds or thousands, or millions of transactions per second, that other end needs to be able to scale and handle the same thing,
Mm-hmm.
right? So that's going to be important. I've worked in my past in systems where the model actually gets deployed and gets linked into the application. So when we build the app and deploy the app, the model actually gets brought right in and as a library almost, and it
Mm-hmm.
runs in the same process space as the application. That's another different situation because now you're looking at how do we scale that entire application and how do we segment out the parts of the app that need to process without certain high cost resources and parts of the app that don't. So, for example,
Mm-hmm.
if I'm building an ML model and it requires GPU, GPU is more expensive than CPU instances on AWS.
Yep.
It just is, right? But if I look at kind of my end to end logic flow, if I look at it and I say, well, 70% of that logic flow is me loading stuff off disk, moving stuff around, doing some other pre processing work that's all CPU level work. And then I hand it off to the model and the model does its work, but it needs a GPU.
Mm-hmm.
I'm paying for that GPU for 70% of the time and I'm not even using it.
Yeah.
Right. So now you need to think about, well, can I bring in tools like step functions or things like that to segregate some of this logic and
Mm-hmm.
simplify that interface? Or do I totally isolate out the ML logic and interact with it across an API call from my other logic? So obviously a lot of it depends on what mechanisms we use to deploy it. Are we just deploying these on EC2 instances or in ECS
Mm-hmm.
containers? Are we actually kind of leveraging something that SageMaker provides for managing that deployment and working across that boundary? Those are the things I tend to think about.
Yeah, and you bring up a lot of good points there, and what I think about too is, okay, it's one thing if you have a model that you've developed and then you put it into an application, and then that
Right.
gets run on the application side. So now there, where it's like, okay, do you just think about it as a general application, and so then that same process is going to be just within the machine learning operation, right? It's
Right.
like, okay, if we're constantly updating that model, though, how do we work that back into the actual
Yep.
CI/CD
Is there
pipeline,
yeah,
and where's the
is there a
handoff?
new model, new deploy situation that has to happen in that
Yep,
scenario?
and there could be a lot of pre-processing done too. So, um, just thinking about MLOps, and I don't, especially within machine learning, there's so many places where you can do all of these different pieces of compute and aggregation. What I
Mhm.
think about is we're going to get to a point where we're just going to be really leaning on a lot of the publishing of data sets like you can do on Redshift, and having different business domains really own the stewardship of that data, but be able to publish it so then the other BUs or verticals can utilize it. But that we're not there yet. When everyone is either managing their own, or there's an enterprise center of excellence, and then everyone has to, there's not that sharing. It's either
Yeah.
one or the other, I feel like.
Yeah, and this actually starts bringing us back to this question of real time versus batch, right?
Yep.
And you know, we're in a world today where we have a mix. We've got a lot of things that are batch. We've got a growing number of things that are real time, and ML is one of those scenarios where you definitely have both,
Mm-hmm.
right? You've got scenarios where you want to apply a model to something literally in real time. As we're streaming data through, we want to derive new information by applying a machine learning model. And we've got other things where we've got large data dumps coming in and we don't need a real-time reply. but we need a very efficient mechanism for taking a chunk of information and running that model across all of the partitions of that chunk or records or whatever it might be.
Mhm. Yeah, I think that is a ever moving target as well, because
Yep.
there's a lot of things that start off where maybe that insight, that one insight or that machine learning application is being used by something else that
Right.
is, and maybe the time sensitivity might not be needed for that application right away, but then if it's starting to utilize other things that are more customer focused, like during that time, then you have to start thinking about how do we change that. And as that's always seems to be a change in technology. So
Yeah.
what I think SageMaker, one of the great things that it does as well is that it stores different elements of your project and your process in a way where you can make that switch, and
Right.
you don't have to reinvent the wheel and start from scratch. You piece it off in different pieces or different parts, and especially like feature stores and the model registry, and being able to automate that as well. So it's not like you're going in figuring out, okay, what one's the best recall. It's like it's doing that automatically, and it's putting that back into that feedback loop. And
That's awesome.
yeah,
That's
so
awesome. So when I think about kind of that whole thing and think about what we've talked about so far, I I see that the MLOps tools in SageMaker are creating efficiency for the data scientists, creating higher levels of repeatability, um, faster ability to do experiments, to track the history of their experiments. Right? There's a reason it's called experiments. You're gonna go to a point where it's like, oh, hey, everything's looking good, and then all of a sudden it's you start
mhm,
going the wrong direction, right?
yep.
So you know I see all of that supporting the implementation, the development of the models. Then we've got another piece that we've talked about, which is around the pipelining and the deployment, whether we're deploying it into a testing environment, deploying it into production. And part of that, I would assume, and correct me if I'm wrong, is the automation of retraining the model, right? We've set our
Mhm.
hyperparameters. We know our features. We've got figured it out, but we're getting new data in that we can leverage as training sets to make this model maybe more effective, maybe more efficient, improve its predictability because we had a limited set earlier, and the other piece is that things change over time, right?
Mhm.
People's
Mhm.
behaviors change, things change, so there is a shift you need to be able to track. So does that kind of automation best happen as part of or I'm sorry, not automation, that retraining as part of an automated pipeline, or as part of the effort of the data scientists, or is there a mix that needs to be applied?
Well, in a perfect world, the data scientists could handle it, right? So,
Yeah,
but
you only
I
have so
think
many people, right?
yeah, yeah. In a perfect world, all the data scientist needs to do is review the model or set what the thresholds are, and then that just reflects all through the system. And
Right,
honestly, AWS does it gives you the ability to get to that point. In
does,
real
does,
world right now, a
go
lot
ahead.
of the times, a lot of the times, that gets pushed to the data engineering teams and gets pushed down, to a lot of the DevOps as well,
Right,
because it's the application side, and it's almost like we got to think of data scientists less of like the people that were the BI folks,
right,
essentially looking at historical data, and look at them more like, hey, these are product managers essentially, in a way that need to adhere to both sides, both down on the infrastructure side all the way to the DevOps and the developers. And because one little change or everyone needs to be on the same page,
right,
because this, Michael, because you work in distributed systems and a lot of machine learning going on at once. If everyone's not on the same page, then you could have a model that's absolutely destroying your whole entire application because of your waiting on it. And
Yep.
I think you know it depends how you set up your CI/CD pipeline, but I think that in a good world, if you were to start right now from scratch in a data science program and you had all of this stuff with SageMaker, you wouldn't have to have that you wouldn't have that problem because you can just expose everything as APIs and endpoints and really have it a part of like a canonical model and make your libraries and make your data sets, make your feature stores, etc. But I don't know, Michael. You tell me what usually does happen. I guess.
It's um, historically in my experiences, the tools haven't been there to automate a lot of this stuff.
Mm-hmm.
Right. So when I need to retrain a model, it's like, oh, I need to go grab a different data set. I need to do some retraining. I need to do some validation. And, I think what's interesting here, and I don't know enough, I haven't dug personally into it enough, but the automation that AWS bring to the table around model retraining, the ability to retrain a model to set thresholds of acceptability.
Mm-hmm.
And if they meet the thresholds of acceptability, be completely dark room about it.
Mm-hmm.
We rebuild the model. It meets the thresholds. We now deploy the model. Nobody
Yeah.
touches it, right?
Yep.
If it doesn't meet the thresholds, we kick it back to somebody earlier on in the process, whoever built the model in the first place, right? Now comes back, something has significantly changed that we're no longer making incremental improvements to the model. We're now losing traction, right?
Mm-hmm.
Something has changed. Maybe the model, the algorithms that we're using don't apply very well anymore because there are confounding factors that are starting to show up, right?
Mm-hmm.
And we need to start going back a few steps and do some more experimentation to figure out what's the right way forward from this point.
Well, I think the best part about SageMaker is that it's monitoring that at every single point, and then you have the lineage, so you can figure out at what point you need to go back to, and then you can reproduce that all again, and you can also share it with other folks, so people can have their input as well. And I had something. I was gonna maybe pull it up, but I don't think I can in time. But also, the really cool thing about SageMaker too is the fact that it can recommend what you should run for inference. It could recommend what you should use at different points, and that I think is huge because there's so many different instances now where I can't keep my head around it. And to your point earlier, sometimes you can get by with CPUs. Sometimes you just need a distributed CPU. Some
Yeah,
models can't even run on GPU or CPU, and so those are the little things that are going to trip you up when you're
right.
trying to get something implemented. So,
Yeah,
yeah.
absolutely true. And the last piece is in my mind again, so you've developed, you've done things to support the developers, you've supported the deployment and the retraining and the all of that stuff. The last piece in my mind, and this is probably more of, coming back to architecture and how you help architects understand the nuances of running machine learning models,
Mhm.
is how do you do this at scale, right?
Yeah.
Not the development and deployment, but how do you run operations in real time at scale? You know, um, it's potentially very simple, if the model returns really fast, but if the model takes a chunk of time to work, or it is extremely resource intensive, there's always going to be that question of, how do I optimize this? How do
Yeah.
I make it scale in a cost effective way?
Yep. And how good is good enough as far as accuracy?
Yeah.
Can you get it done with a logistic regression model at 92%, or do you need that deep learning model at 99, and that's costing you 50 grand a year to process? So
Well,
it's
it kind of goes
over
back
that
to
whole
some of the,
trade-off.
yeah, it kind of goes back to some of the conversations that we've had in the past about, you know, data quality, right?
Yep.
You know, data quality isn't defined by just a number, right? Everything has to be X. Data quality is defined by good enough for use, right? And I always joke about, if your revenues are always off 10% in the same direction, but all you really care about is the trend, are you growing or are
Yeah.
you shrinking? It doesn't matter,
Yeah.
right?
Yeah.
You're not looking at the actual numbers, you're looking at the trend. Now, if you need to report the numbers and they need to tie back to accounting because you're using this as a report that you give to some external agency or something like that, now your data quality needs are different around that particular data set. So I can see the same thing on the ML side, which is, you know, is 95% good enough, and is the cost to go to 99% an acceptable cost if 95 isn't good enough, right? Or do you
Hmm.
say, you know what, considering the cost difference, 95% actually gets us what we need?
Yeah, and then that all bleeds into workloads of the data scientists too. Is like,
Yep.
at what point do we say, okay, this is good, then we're going to switch gears here? You know,
Right. Right.
there's a lot relying on it, and it's not just the compute, which is expensive enough. It's those expensive data scientists as well that are going to
Right.
be working on stuff.
So do you see people kind of in the same process doing A/B testing of models in production?
Well, it's the old saying, A/B testing is dead, right? But yeah, I mean, you can do. I mean, you can just. That's what I think the experiments can be run. I'm not correct. I might be wrong here, but I believe you can reflect everything that you're doing in production. You can have that all those results be reflected, and either it's stored in the model registry, or there might be other things within the experiments. That'll be a good follow up. I'll have to dig into the experiments and some of those
Yeah.
capabilities.
And it's to me, it's an interesting question, because you start to ask the question of, the model may predict something, but oftentimes when I see organizations using machine learning models, they're trying to influence some sort of outcome, right? So in the retail space, it's about recommendations and getting people to add things to their cart or things like that, right? And it's not the prediction of the model that's important. It's whether or not somebody actually takes action on that prediction, right?
The uplift, yes.
Yeah, it's the uplift, right? It's, are we actually seeing the uplift, even though, you know everything looks good from a training and testing perspective? Is consumer behavior actually changing, right? Is doctor behavior actually changing because of what we're doing? And there's an interesting blend of line there, which is, how do you enable that? How do you track that? How do you A/B test it if A/B testing is the right thing? If I've got a couple of approaches, they seem to give us, they give us slightly different answers. Maybe one is better than the other. I remember way back in my earlier life, back in the early days of collaborative filtering and recommendation engines. I did a lot of work in that space,
Yep.
and we were part of a deployment of a recommendation engine into a catalog call center. And people would call in and say, "Oh, I want to order these 5 things." And I remember people 'cause we had just turned this thing on and we're watching. It was one agent was um, was using it. We wanted to see what happened, and this person called in, and they're making all of this, requesting all this stuff that seems to be health and diet related, right? I want to buy the dumbbells, I want to buy the scale, I want to buy, the treadmill,
Mhm.
these things. And then the recommendation engine came up and said, try selling them a grill. And it's
Grill.
like, you kind of,
Yeah.
you walk away after scratching your head, and then you realize, you know what? People who want to lose weight, they like to eat.
Yeah, yeah, yeah. That's true. That's so. Yeah, you know what? That is a classic. That's like beer and diapers too.
Yeah, exactly. So I guess
Market that shit.
I guess that thing brings us to a potential whole nother topic, which is ethics. and,
Yeah.
And, is that actually an ethical recommendation or is that not an ethical recommendation, right? If somebody's trying to achieve a certain goal and you're recommending things that might divert them from that goal.
Well, that's kind of the thing, the interesting update that just came out with personalized too,
Yep.
is that you can add your business goals in there a little bit as well. So it's recommending the thing that's either on sale or that you need to sell a bunch of. It's recommending that just a percentage more than what the other actual recommendation would be. So I find
Yep.
that pretty interesting as well.
Yeah.
So a project is going to be able. So circling back, a SageMaker
Right.
project is going to be able to encompass everything in the CI/CD experiment just for the training portion of it. So,
Excellent.
and then within a project, can go to the models can go to the model registry. Results can get stored. The whole nine there. So,
Excellent.
little
So are
clear.
there other topics around MLOps on AWS that we've not touched on that are important to touch on?
I was gonna say about the project. I'm just kind of looking through here, making sure we didn't miss anything. I guess my question, I want to kick another one back to you, is that if you're trying to build an application that is going to be using extremely intensive models that could, not necessarily on the training side. Well, obviously it'll be an intensive model, but even the inference side, or maybe there's an ensemble model that has to happen, or maybe you deploy a multi-model endpoint. Where is that logic going to come to pick how the ensemble is going to run? Should you try to run it within that model, or do you think it's the more you can do with the application, the better?
Yeah, it's going to come down to a few things. Is granularity of scalability. Where does all the processing have to happen? Cost optimization, um, maximizing use of resources, right? So if making those decisions as to how that ensemble comes together, or if we're selecting between types of models based on a particular data set coming in,
Mm-hmm.
right? Oh, it's this kind of thing. I really need to apply this model because that model's optimized for this type of situation.
Yep.
Where the
Yep.
other one comes in, and I have a second model that's been optimized for that one. Um, you know, if all things are equal, right, and the models are running on CPU and things like that, you could keep all that stuff together. Um, when you start having to run very expensive devices, whether they're very high end CPU or GPU based or specialty, you know, um, instances just for certain types of ML models, then you're looking at how do I minimize the amount of non ML processing that is running on the instance with the ML,
Mm-hmm.
because I want 100% of that thing's resources executing the ML,
Mm-hmm.
right? Because that's the way I'm going to get my best return on it, right? If I've got threads that are quiet, not doing anything, I'm paying for it, not getting anything out of it, right? If I'm spending part of my load doing a little bit of data analysis and that runs the CPU at 20%, and then the model runs it at 100%, I'm paying for something that I'm not using for a period of the time as well, right?
Mm-hmm.
So these are really nuanced kind of things, and you really have to kind of look at your load and model.
Yeah.
And you can leverage things like a combination of EC2 and ECS and step functions. Um, if you want to be highly structured about it, step functions give you a way of structuring the flow. So you can kick off a step function flow, and it'll say, hey, we're going to do this pre-processing of the data, we're going to do this interrogation, determine which model, we're going to branch, we're going to execute this model or this model, we're going to come back, do this post-processing of the results, right?
Mm-hmm.
You could go with a purely event-driven piece, right, where the models as well as other pieces of code are listening to an event bus for certain types of events
Mm-hmm.
and posting events with the results, right? So you can orchestrate your flow that way. But cost and scale ability become a fairly big factor here, right? Um, in addition to um, what's the term I'm thinking of? Um, in addition to speed of response,
Hmm.
right? So if you need response within a second or two,
Latency.
yeah, yeah, the latency of the response. Thank you. Showing my age. All my words have gone.
Yeah, every day.
Yes. So if you need a really low latency response, you need to make sure that you're scaling quickly and that you always have those resources available, right? If that response can wait, tens of seconds to a minute or two, then now you can take and say, well, tell you what, I can spread my load out and minimize the number of resources I'm applying, from an AWS service, EC2, ECS, whatever way, and leverage an asynchronous mechanism like a queue or something like that to
Mhm.
basically buffer up that work and let a smaller set of instances just chug through that, right? And then you could use queue depth as a mechanism to say, okay, we've built up enough here. We probably should scale one and add another one for a little bit
Mhm.
of time. But in that model, you can say, if I've got a big peak at noon and then it drops down, you know, I can scale up a little bit to handle that peak if I've got a minute or two to process. But then as it goes down, I can just let the queue build up and just process them through.
Mhm.
Right.
Mhm. So you're
So
not even worried about it on the back end.
yeah, so when you architect, you really need to look at all of these different factors, right? You're always balancing. In the end, you're balancing cost and scalability and reliability.
Yeah, and then is it a model that, hey, maybe you can use a spot instance, or maybe it
Right.
can start now and end
Right.
later. So
I mean, and as long as you've got the ability built into the architecture to retrace if the model, if the execution of the model blows up, you know, are you set up that I can spin up a replacement and I can recover in a
hmm
period of time, right? If I need, tens of milliseconds response time, and obviously the model can run in that time, now I might have a different issue because now I'm getting more into I may have to do a circuit breaker pattern. So if
hmm
something doesn't respond in a certain amount of time, I express that request to another instance
hmm
because the latency's grown too high on the one that I did request it from. Yeah.
yeah, or or you just there could be situations where, hey, maybe it's not doesn't work. Even if you try the new one, it doesn't work either. Then you have to have like another way to say, okay, this isn't a required thing in other parts of the application, so the whole application doesn't crash. Maybe you just get a little a little replacement thing, or whatnot. So
Yeah, and this is where you get into, and this is what I've been seeing a lot of recently is as people move to the cloud, they're moving from stuff that runs on a server to stuff that is spread across many servers.
hmm
And with network issues and things like that, sunspots, things that
hmm
cause errors, right? And the concept of a system throwing an error is less important than the ability to recover and retry and be resilient to those errors, right? Building and architecting a system, whether it's ML or based or not, that understands that stuff happens and assumes that stuff is going to happen and
hmm
recover from it. That's what you want, right? I was working with an organization recently. They ran a test on a distributed system we built on AWS, ran 500,000 requests through it. It threw a couple hundred literal errors, but every request processed properly
hmm
because the system was designed to assume errors would happen,
yep.
and they all look like network errors. We look like corrupted data that got sent across the network. But
So that brings that brings up a good point too, and not cutting any corners, and not you have to really develop and also have your capacity and understanding that, there's going to be a lot of retries, and there's going to be things, and you need to build it with the resiliency, your redundancy, and just resiliency even within the application, not even all of the architecture too. So
yeah,
that's an interesting factor of it too.
well,
And all
it's
of this has machine learning that needs to be a part of it too. So
yeah,
just
and attitudes need to be different, whether it's machine learning or not, when you get into distributed systems. I
Yeah.
remember I went to the first ever AWS reInvent conference, and one of the principal engineers was giving a presentation on building for reliability at AWS. And he shared a concept that has kind of stuck with me ever since, which is most of us, when we buy computers or or servers, we have hard drives, and these hard drives have a mean time between failures, right? So what you do is you plan. Oh, the mean time between failures on this hard drive is 4 years, right? So you get a backup hard drive. You know that around that 4 year mark, plus or minus, you're going to have to swap that hard drive out. It's going to fail, right? Amazon, on the other hand, doesn't deal with that. What they're dealing with is how many hard drives fail a day,
Hmm.
because they have so many of them doing so much work that they have hard drives fail every single day. So their entire architecture isn't built around how do I prepare for that time when a hard drive fails. Their architecture is built around how do I handle hard drives constantly failing.
Hmm.
Yep. And it's the same thing with any of these architectures at scale. As you deploy your machine learning models, you have to think about what happens when they fail. Let's assume they do, and how are we going to recover from that?
That is a really that is a I that one's gonna stick with me too because it's kind of like cybersecurity. Everyone starts thinking about cybersecurity after they've already built the application and built everything. Where it's like it's the same thing with just the resiliency. It's you don't think about it until you're kind of already started to put a good
Yep.
portion of the architecture together, and then you're like, oh wait, okay, if this thing fails here, there's no way that the rest of the system is going to be able to recover for that. Or maybe something's already started to kick off that needs to link back up here. And yeah, so, that's a really good point. And I don't think it's any more evident than in something like a machine learning workload where there's a lot of times things are going to fail. I mean, there could be one little aspect that's different and to make that fail. So,
Absolutely. Well, we're starting to run a little bit far afield from the topic.
yeah,
Do you have
yeah.
anything else that you want to touch on before we wrap up for the day?
I think I'm good. I think we covered pretty much every portion of the machine learning process and talked about a lot of different tools that you can use. And then we got down the rabbit hole of how that goes into distributed systems, which is always good too. So
Yep.
I'm good.
Excellent. Well, that's all then that we have for you today, everybody. Thank you so much for joining us, and we hope you've learned something new today. If you liked what you've heard from us, please subscribe or to either our podcast or our YouTube channel, and join us again next time for another fun and interesting topic. Thank you.
See y'all.